My name is David. Most people call me Dave, but I answer to both. I work for Test Double. I'm a staff software consultant, and I've spent my career in equal parts between general consultings on software and systems and the startup world, which is an interesting blend. My hope today is to share a little bit about that background and story and frame the conversation a little bit about how I discovered Agile and some spicy opinions that I have about Agile. The goal today is to give you some concrete tactics that you can apply to your teams, your processes, or just to get you thinking. The talk is called Ratcheting to Zero and How Incremental Constraints Eliminate Technical Debt. A little bit of backstory. I mentioned my introduction to Agile was actually in that startup ecosystem way back in 2007. The leadership at that startup introduced me to the concept of the Agile Manifesto. One of the things that I enjoyed was it was a new way of thinking. In the example that you can see on the screen here, often the things on the right, processes and tools, comprehensive documentation, they describe a little bit about how, but the emphasis in the Agile Manifesto is often on those things on the left. It's not that processes and tools are not important. It's that we prioritize or place higher importance on individuals and interactions. That, in summary, is a good way to think about my introduction to the Agile process. I was working at a startup, and the leadership was really focused on those things on the left, almost to the detriment of the things on the right. And I think when I've reflected on how that influenced me as an early stage Agilist, a new software developer at a startup, I was constantly asking, where's the process and tools that can help us emphasize the importance on individuals and interactions? For me, one of the things that emerged was the conversation about technical debt. I found the leaders that I was communicating with at the startup would talk about why it was important to address technical debt, but there wasn't a clear answer how you would do that. That gap I've seen play out over the last 20 years of my experience, where technical stakeholders with deep knowledge understand that it's important, but they lack the concrete steps to roll out incremental improvement to address that tech debt. And we'll talk a little bit more about that today. We know the why, but the question that we want to answer was the how. And the technical debt conversation is what we want to frame it in regards to. And really that secondary question that I think a lot of leaders are looking to us to answer isn't just how, but it's how long and how specifically are you going to solve the technical debt? If you're telling me that it's important, I'm bought in at the leadership level, but I need to see a clear path to figure out how you're going to solve it. This kind of ties into maybe one way of framing my experience with Agile, and I like to call it big A Agile versus little a Agile. And whereas big A Agile is very heavy on the why, and I've experienced a prescriptive process for some of those things, little a Agile emerged out of my experience at startups where we needed to adapt. We needed to figure out the how. And those prescriptive ceremonies and things that I've experienced before, you might think of them as Scrum or the length of your iteration or how you do sprint planning or planning poker, these prescriptive processes fall a little short. I like to frame it as little a Agile. And the emphasis there is, what's the process that needs to emerge? What are the steps that need to emerge? How do we need to adapt as we're reflecting on things that we're seeing in real time in an organization so that we're not painting with too broad a brush when we prescribe processes, but we're getting the team involved and surfacing those things from the ground up and adapting to get to the how. So let's talk specifically about this concept that I'm introducing called ratcheting. This is a concrete technique that I've seen work well, specifically to get to that how. And it's really good at addressing the question that leaders ask. How long is this going to take? And what are the granular steps that you're going to take to solve this problem of paying down technical debt using ratcheting? The scenario that I want to describe to you is an experience that I had in my second startup that I worked at. The story was we had a JavaScript code base and TypeScript had been gaining significant momentum. And as a team, we felt like we had a ton of uncertain technical debt in our JavaScript code base. And the theory or the promise of moving to TypeScript was, hey, if we port over, we get static compilation, we can see the value immediately. It'll tell us what we're doing wrong, detect problems, and hopefully prevent bugs. So that was the promise. The approach we took at this startup to address that unquantified amount of technical debt was to do a one-time migration of our JavaScript code to TypeScript. That was an interesting decision, but it led to some pitfalls along the way. I want to use that story to frame the conversation around ratcheting as the approach and how ratcheting didn't start as our strategy. It emerged as that adaptive approach that I was mentioning. So we did a one-shot migration of our code base from JavaScript to TypeScript. It was like, yay, we're in TypeScript. And then we had a static analysis tool called ESLint, which is fairly popular in the front-end ecosystem. We layered that on top of our CI/CD, and immediately we got hit with this massive amount of ESLint warnings. And so that an immediate hands-on head moment, what have we done here? Have we just surfaced the amount of technical debt that was there? It made it immediate and it brought it front and center, which is probably a good thing if you're in an environment where you don't have confidence about the technical debt. So when we did that one-shot migration, it was more than just those red lines that show up if you're working in your code editor and you get the annotations from the TypeScript compiler. The naive approach to that is to just use the TypeScript any type, because that allows your build to still compile. That led to a real false sense of type safety. We were using TypeScript, but we weren't gaining a lot of the value out of it. Our developers were left scratching their heads and had a bunch of question marks. The biggest question was, did we actually make things better? Now we know the size of this technical debt. We've put a number on this cost that we were speculating about when we were in JavaScript. We could see it show up in TypeScript, but a lot of questions surfaced. The leadership who had blessed our approach to do the migration immediately started asking big questions. How long is this going to take? And what's our strategy for dealing with this massive amount of technical debt that we now see in front of us? Our goal was to get to 0 warnings, starting from that large number. We did it over 292 days. And I want to share a little bit about what I think worked well in that process and some takeaways that can prompt your thinking, get the gears turning, and give you some tactical conversation points that you can take to your teams. Reflecting back on that beginning framing about Agile helps to bridge the gap between why are these things important, the things that we value in the Agile Manifesto on the left, and a bit more of the how, which I'm representing as the things on the right. There's this big chasm, this gap from getting from why to how. And so I'm hoping to lead you through that. The first step we took, and I think this is a really good thing to start with, is doing some analysis to understand the scale. We had that large number of ESLint violations. There's a number of specific rules at the granular level when you take a look at analyzing that. One of the things we were interested in was the impact of each one of these small granular rules. If that one-shot migration I mentioned is dealing with sprinkling everywhere just to satisfy the base case to port a code base from JavaScript to TypeScript, how do we deal with that specific rule? What's the impact to developer experience? What's the impact to the user? Can we quantify it on these individual rules? We started doing an analysis, and I took a look at all of the ESLint violations in our CI/CD once we had rolled this out. I took a count, and then we had a discussion as a team. We organized them by priority. What are the high priority things? We tried to shift things that really affected developer productivity to the top of that list. This first rule you see there broke hot reloading in development and was really negatively impacting dev experience. And we could clearly draw the line from this violation increases the amount of time it takes to do development because we have to reload the page X number of times. So it was an easy way to quantify the impact of that over the volume of these things. We went through this process, and I think analysis and getting a sense of the state of the world, if you have some amount of technical debt, is a good way to stack rank these. And then that lets you feed into an approach and a plan that you can use to tackle this technical debt. So let's talk a little bit about the ratcheting idea. And if we think about the metaphor of a ratchet, I'm using it. I have a socket set at home. I was using my ratchet to remove a hard to extract battery from my lawn tractor last week. I live in a rural area and I have to mow my lawn on about a 3/4 of an acre lot. And I needed to replace my battery because we're in spring. And so I got a ratchet with a deep socket set. It was in a hard to reach place, but I could extract the bolt necessary to remove the battery because I didn't need full range of motion. I could incrementally ratchet my way to removing that bolt to remove the battery from the lawn tractor. And that's a really good metaphor for approaching technical debt. We want to get to a place where the strategy and the implementation of our approach to addressing technical debt allows us to move forward incrementally, just like I can use that ratchet to remove my battery from my lawn tractor with a limited range of motion. We want to have a lock in progress so that we don't have to backtrack. We have a clear set point, a new high watermark that we're moving forward from. even if we're ratcheting. So this conceptually breaks down into kind of 4 areas. We want to set the maximum number, for our case, of ESLint warnings that we're going to allow. We want to build a script that runs in an automated fashion in CI/CD so that we don't have to do this manually. And we want to block any regressions in that script that would allow that number to increase. So if we set our high watermark to a specific number in our ratcheting script, then our CI/CD will automatically fail and block a pull request or a new contribution that increases that number. And the fourth one, the keyword here is adapt. And harkening back to what I mentioned at the beginning of the conversation, what emerged over time was we needed to be adaptive and flexible in how we approached rolling out this ratcheting mechanism. Here's a idealistic view of what we wanted. We want this chart that's counting the number of errors over time to go down to the right as time increases. And along the way, there's some signposts and some things that have emerged in retrospect that I'm going to walk through and tell you a little bit more about. This is maybe the ideal, but it doesn't always play out that way in practice. And so I'm overlaying here the actual graph of our GitHub commits to show you that our down into the right trend line doesn't always play out that way. Sometimes we have plateaus in contributions for various reasons. And sometimes we have massive drops based on the team really rallying and figuring out maybe there's an individual contributor who's really passionate about paying down this technical debt. When we started this, I've broken this up into 2 phases. Here was our total number of ESLint warnings. And we had some initial progress as we moved along the trend line, but it wasn't until we really thought about what is our strategy for ratcheting. Right here, when we had this big initial drop, was when we had a team discussion. We talked about ratcheting. We implemented the ESLint script that I'm going to highlight a little bit later to approach paying down that technical debt. Once we had the strategy, I think reflecting on the why behind why we saw such a dramatic drop, it was invigorating to see that we had a plan and it was working. And we had a move from day 107 to day 111 where we paid down 531 of those warnings that we were dealing with. And then we hit a 0 point. The 0 point was that initial set of high priority ESLint rules that we had come up with and prioritized in that stack ranking chart. You'll notice there was a bump back up here. And the idealist in me thinks the trend line should always go down. It should never increase. In reality, the pragmatic approach says that we tackled the high priority issues. Let's crank our warnings back up and take care of the next most important set of medium priority issues. That's the rhythm that we got into. And that's what the plot here shows. And there was a couple of other spots where we had increases that I'll talk about a little bit later. But the goal is to give you overlaying my real lived experience with the ideal case we want to make to stakeholders or leaders when we're talking about paying down technical debt. My intent in sharing this is to give you real world knowledge and insight, both to equip you to know what to expect and to have conversations with leaders about their realities when we have to go back up and then pay down, and then go back up a little bit and pay down again. So this is conceptually what I was just mentioning. We did that assessment phase. We hit our strategy where we just had a mad rush of activity. We needed to figure out how to grapple with existing lower priority rules. We did our config reset. We raised our cap again and continued to pay things down to 0. And the power in this really came through that CI/CD script that I mentioned. We had a shell script that tracked key variables and implemented the ratcheting mechanism, and that we saw the team get on board with once we rolled it out. I mentioned upswing in the curve and why we need to be flexible. One of those scenarios, maybe there's a production fire that happens, and this happened in our case. And if as a team, we've agreed to the strategy of ratcheting, we've implemented it with our CI/CD script, we're paying it down incrementally over time, we're getting buy-in from lots of people across the organization, and then somebody on call hits a production fire on a weekend and needs to bypass that rule temporarily. And there's 2 sort of minds you can have here when you're approaching this. It's like the rigid approach is to say, sorry, we've got this rule in place. We've got to pay down the tech debt. We can't deploy to production until we fix this. That doesn't fly in the startup world. And so we need to be flexible. In our case, we just added a bypass mechanism to be used sparingly for a scenario such as this. But when we did that and we communicated that with leadership, that just reinforced their confidence that we actually had a plan that would adapt to the needs of the business, to be able to push it, deploy to production in spite of increasing the number of warnings and incurring some short-term technical debt on the way to paying it down. And so this built a lot of trust in the organization, and our leaders were able to see that we were thinking about things rationally instead of dogmatically. I feel like that is a theme that I've seen play out in my own experience over software consulting and the startup world over the last few years. As Agilists, it's often easy to lean into the dogmatic things on the left of the Agile manifesto and maybe de-emphasize those practical things on the right and tactical things. Long story short, we hit day 292 and we got to 0 warnings, and our team celebrated, because it's worth celebrating when you pay down technical debt, especially if you've had a lot of insight and adaptation required along the way. The impact of that was definitely felt in our team. Our leaders joined with us in celebrating the pay down. And how we got there, we were hitting this downward trend. We had some upswings. We adapted in the moment. Our rule was we just wanted to eliminate regressions, with the exception of the production exemption. We tracked it over time. We didn't have fancy charts and graphs. A lot of what I'm showing you has been analyzed in retrospect, looking at commit logs that tracked changes to that specific file. But on a day-to-day basis, our CI/CD server raised an error and showed you exactly when your pull request increased the limit of ESLint warnings beyond the threshold that we had set. So it was a really good virtuous cycle to work in this way. And it had an impact, not just in the technical side of paying down the tech debt. We saw a cultural shift in the number of people who contributed. Our team started to form and group. If you're familiar with Tuckman's stages of group development, storming, norming, forming, performing, we went through that in a microcosm. It was interesting to see the impact on the team. One of the dimensions that I analyzed as I was looking at contributions in our Git logs was we had some unexpected allies. And by that, I mean, we're talking about a front-end task, and we were under the assumption that the front-end folks would be the ones taking on the lion's share of paying down this tech debt. As we looked at the results in the Git log and we saw more and more people start to contribute once that strategy of ratcheting emerged, we had way more back-end people contribute than I ever thought. I think part of it was because we were trying to get everyone's input. The most meaningful part, I think, that reflects this distribution of who contributed was having a process, having a strategy, and seeing it work, seeing that slow incremental pay down of technical debt. We had folks from full stack disciplines, and it was nice to see the split. Usually the back-end developers stay in their back-end, the front-end's in their front-end, and they don't tend to roam. But we had contributions from people of all disciplines. We also had a good mix of contributions across seniority, including some interns, junior, senior, and staff, and this represents the breakdown. And so you can see we had a pretty even distribution between different levels of seniority as well. The fact that we saw success in how we paid this technical debt down using ratcheting and the distribution across discipline and seniority makes me feel really good about the outcome here. Some takeaways and details about the specific ratcheting approach in CI. Make it big and visible so that everyone can be held accountable. We didn't have any charts or graphs, but you could go onto GitHub, see the pull request, and see that max warnings variable that we had set, which is our high watermark point for the ratcheting script. That just changed over time. You could, as a developer, when you were working, you would see that change daily. And we found team members started just randomly dropping Slack messages, celebrating the wins to say, hey, I reduced it by 50 warnings, which was a good way to build camaraderie and have people contribute and celebrate small wins incrementally over time to contribute to that ultimate goal of getting to 0 warnings. Here's some details on the actual code. This is pseudocode, but conceptually, this should give you the idea. So we had a shell script that we added and was triggered as part of our CI/CD run in GitHub Actions. And that high watermark existed. We had a maximum number of warnings. Conceptually, you can think of it as if our warnings is less than or equal to the max warnings, then we need to proceed. We also adapted our shell script later on to fail the build if somebody failed to update the max warnings. That's the ratcheting mechanism in effect working. We continue to lower that over time, and people take responsibility for updating the ratcheting script alongside their code changes that are lowering the number. We had this magic number that set the ceiling. We had some new pull requests that came in, and we changed that number over time to lower it. That led to this self-reinforcing loop where we were locking things down, getting to that new baseline. We would lower the value in the script. We might see a build regression, work on some changes, address those issues. We wanted to prevent that regression. Our build ultimately passes, the warnings decrease, and we just keep working in that loop as we're iterating on development tasks. Ultimately, one of the amazing takeaways that I want to leave you with is if you're struggling to address technical debt and you're thinking to yourself, how would I go about implementing this? My encouragement to you would be to not go it alone. It's dangerous to go alone. And ultimately, the best solutions that I've seen to problems emerge when you get everyone on board thinking about the strategy and contributing to the challenge, whether they're interns across discipline. Shared problems are ultimately best solved by shared solutions. And not to say that individual contributions aren't valuable. We had a number of team members who spearheaded the effort. That's important to recognize. Over time, they were able to let go and support other people who came in to solve the problem. The results speak for themselves. We had 3,300 warnings. We got to 0 over 10 months. Our first month or two was a little tenuous as we didn't really have a strategy, but ultimately we were able to pay this down over those 10 months to 0. And it really solidified in my mind that this ratcheting approach is a concrete way that you can pay down technical debt, and it makes a lot of sense. The other takeaway that I want to share with you is you might think that you can just have a conversation about this and get everyone on the same page. And then magically, through the process of development, if we norm on these conventions, maybe we document it somewhere, but we don't take the step to automate it. That's a mistake. Good intentions don't scale. I've seen that. So wherever possible, automate these things so that the cadence of development is impacted and the sharp edges that exist in these warnings and implementations are there for a reason. They're there to cause us to think about the work that we're doing. And remember that we set a goal to pay down this technical debt. We have that automation as a guardrail to keep us guided in the right path. One other purely technical takeaway, if you're doing a one-shot migration from JavaScript to TypeScript, you're going to end up in this state where you're in an anyfest instead of actual type safety. That was where we started, and it wasn't very valuable. We didn't get a lot of value out of the TypeScript compiler until we paid down each of those lint rules using ratcheting over time. And then our code was actually useful. We had meaningful types for things, and our editors could save us time and prevent us from making bugs. If you're considering a similar migration, ratcheting is a great way to actually realize the value of TypeScript in a front-end code base. Another takeaway I wanted to mention, I hinted at this earlier with the story about the production emergency. I think our ideal is that we would be going down and to the right, and sometimes we need to adapt and incrementally ratchet the wrong way. There's a reason ratchets have a toggle switch so you can go back the other way, right, if you need to. And that's conceptually the metaphor here. If you've got things that you need to respond to, being adaptable and being flexible to adjust back up, it is a good thing to build confidence with your leaders as you're coming up with a strategy to pay down technical debt. This leads to the rhythm of improvement, those guardrails that I mentioned, that slow, steady climb, everyone contributing, and that ratcheting mechanism in work to get down to 0. It feels empowering to see other people participating as well. There's no contribution that's too small. We had some people who, looking back in the Git history, only committed a couple of pull requests that actually impacted this, but they still did it and it contributed to the goal. It's really nice to get into that rhythm of improvement. The other takeaway prompts thinking about how do we shift the conversation. I mentioned that story of working at a startup where we were wanting to go through the Agile motions and we really understood from the leader's perspective why it was important, but we didn't have the right tools to engage with that important question. How are you going to do it? And how long is it going to take? And ratcheting is a great way to stay engaged in that conversation and equip your leaders so they understand how you're going to do it and some sense of how long it's going to take. I think in retrospect, with time and space and the analysis I did for this talk, I probably have some spidey sense for a code base of a given size for this many lint violations. Here's an approach you can take and roughly how long it would take. Your mileage may vary. Your project might have more. How long is important to address roughly, but estimates are always hard to get right. The how is much more important and showing incremental progress over time. Small wins lead to a big impact. We had contributions from people, multi-disciplines, multiple levels of seniority, small incremental chunks at a time, 25, 50 warnings here. Sometimes we increased it back up. All of that is greater than the sum of its parts. We added up to paying down that huge chunk of warnings over time. The lasting impacts on team morale, understanding that everyone was bought in, trusting each other, added up to way more than just reducing that number of warnings to zero. Thinking about this is a great way to avoid what some teams struggle with, which is, let's just bucket all of our technical debt stuff up into a tech debt sprint. Let's focus for 2 weeks. Maybe it's a week, maybe it's a quarter. Maybe your company uses hackathons to address tech debt. I think that's a mistake. And my advice is to amortize the cost and integrate those fixes over time. It's not that concentrated efforts aren't wrong. It's that in my experience, tech debt sprints don't succeed in the same way that I've seen this distributed effort and in ratcheting approaches over time. It also shifts our priorities. Maybe it's appropriate in smaller doses, but I think holistically, moving from delayed attention on technical debt to just continuous attention through these guardrails is a better way to help the developers grow. It's a better way to focus on the problem and surface it. It's a better way to communicate with leaders. It's a better way to show progress over time. So yeah, I would say my advice here is avoid tech debt sprints if you can, and come up with ratcheting processes and tools that you can implement to show integrated processes and progress over time. One of the last takeaways is I've focused specifically on applying ratcheting to paying down static analysis violations that we had in our migration from JavaScript to TypeScript. But you can apply this universally. Maybe you think test coverage is an important metric. You could still apply ratcheting to increasing your test coverage or getting to a strategic number that is meaningful for your team. The same is true for accessibility audits, reducing legacy code, increasing the amount of documentation that you have, doing web performance analysis. Maybe you want to audit and remove dependencies that are really crufty and quantify that with lines of code impacted, number of imports, number of packages. Anything you can put a number to, ratcheting is a great way to tackle incrementally and over time. That's what I have for you today. And my hope is that this has got you thinking and given you some concrete tactics that you might already see an opportunity to implement in your teams. My hope is that you would be able to answer the question, can my team use this? Who might join in the effort if I could cast the vision, have a strategy, have a plan, and how long do I think it would take? What kind of conversations would that change for me in my organization? How would that help my leadership understand the value of paying down technical debt more concretely with more emphasis on the how and less on the why, especially if they've already bought into that? This has been Ratcheting to Zero. And my hope is that as we've talked about it, you'll see that it's a better way to frame managing technical debt. This is the loop. We analyze where we're at, set that high watermark, we iterate to drive to zero, we automate it so that we've got the guardrails, and then that's the path to success.